Also, there is IETF 113 being organized from 19th to 25th of March, and it's physical as well as online. The location is Vienna this time, and we have a free waiver option available for those who want to attend online. Now on your screen, you must be able to see poll option, and there you will have some questions. You can also see my screen. This is something similar you should get in your Zoom panel as you click on poll. And we would like you to quickly answer this. So for the first poll, it will close in a while. So please answer fast. How many of our events have you participated before?
Printi, I'm going to click on the end poll so we have the numbers.
Okay. Thanks everyone for answering.
So lots of new people. So welcome.
That's exciting. Okay, so I can move to the next slide. Okay, so we have the second poll question on your screen.
There's only one poll.
Okay.
We can move ahead now.
We have the results now, all right. So talking about connections, as I said, it's an annual flagship event where we try to bring in protocol developers, vendors, enterprises, and network operators together and discuss about the latest problems in the internet and figure out solutions collectively. So the first event that we did was in Bangalore, and later we also had a physical meeting in Kolkata, and this is always a full 5-day event, and even this time we are going to do a full 5-day, but it's going to be online. In the year 2020, we had a physical event, and we had a lot of exciting talks on enterprise security, hot topics, and IoT, and several other topics. And we try to bring in experts and pioneers in the field of networking and several long-term IETFers as well. We have a number of exciting panel discussions, and you can, if you're interested, you can find the details on our website right here, connections.iiesoc.in. This year, we have decided the dates as 4th to 8th of April, and the timings would be IST 19:30 to 22. So it's pretty convenient for most of the folks in India, I believe. And this time we are collaborating with INTC for the organization of this event. And some of the key themes that we have decided upon are IPv6 extension headers, IoT, and hot topics in networking. Discussions are still in progress, so there'll be many more exciting topics. And some of our finalized speakers as of now are Bob Hinden, Paul Vixie, Adrian, Carsten, who are really great people in the world of internet. So really look forward to having you all there and join the exciting discussions. We have a number of panel discussions planned this time as well. And also we have a pre-event on 2nd of April, where we are trying to facilitate the newcomers with the workings of IETF and what exactly connections is going to be like. Lastly, this year, we have started a formal membership, which is totally free. So if you are interested, please become a member. We are sharing the links to the membership option in the chat window. This would help us stay connected with you guys. And we also have a free open mailing list where we have most of the general discussions and also a direct email. So you can connect to us with that. We also have our social media handlers on Twitter, WhatsApp, and Facebook and LinkedIn. But most commonly used channel for us is WhatsApp. So you can directly join the group and stay connected with us. So without further ado, I would like to kick off the meetup with some general housekeeping rules. Please use the Zoom Q&A option or raise your hand if you have any questions at any point of time. We'll try to take them as fast as possible. And for other general discussions, feel free to use the chat option. This RFCs we love, as I said, is very special because we have 4 working group chairs from India talking about their respective working group and their experiences. So we have Pavan, Shweta, Thiru, and Dhruv, and all of them come from diverse backgrounds. So we have the T, 6LO, T, and PC working group representation, which is indeed an honor for us because when we started back in 2017, we were working for ITF, we were collaborating, but we did not have any chairs from India. And I feel very proud to say now that now we have 4 working group chairs from India and all of them are here with us today. So without further ado, I would just like to kick off with inviting Pavan to join us and speak about his experiences. Pavan is a co-chair for the IETF TEAS working group, and he has 20 plus years of software development experience. He has been a very integral part of the Juniper routing protocols development team and has been working on the control plane solutions and MPLS-TE features for a very long time. So Pavan, thank you so much for helping us out, and I'd like to hand off to you now. Thank you, Pavan. Thanks, everyone.
Thanks, Praneeth. Thanks for the very kind introduction. Thanks to the organizers for putting this session together, and uh, also thanks to all the attendees, especially the first timers, as the poll showed. Very exciting. Thanks for logging in on this fine Saturday morning. I do sincerely hope that the rest of the speakers and I can really make this worth your while. My name is Pavan Biram. I am a distinguished engineer at Juniper Networks. I'm part of Juniper's routing protocols development team, where I'm responsible for driving innovations in the traffic engineering space. I work out of my home office here in Hyderabad, and like all of you, I do hope that we could do these sessions in person again sooner than later. Um, for the past 7 years, I've been serving as the co-chair of the Traffic Engineering Architecture and Signaling Working Group in IETF's routing area. And that's the capacity in which I would be doing the talking today. There is an IETF session coming up next month. It would be the first for this calendar year. So as working group chairs, this is perfect timing. What better time than now to evangelize some of the work we have been doing at the ITF in our respective working groups. In terms of the narrative for the next 15 minutes or so, I will give you an overview of what traffic engineering means in the ITF context. I will give you a sense of the charter that we have for the TEAS working group. I'll provide some highlights from past work, and then give you sort of an overview of what's currently going on in the TEAS working group. Also, as a working group chair and a seasoned IETF participant, I'll give you some pointers on how you can get involved or can increase your involvement at the ITF. And before I conclude, I will talk a bit about my journey at the ITF, how it started, and what this whole engagement with the ITF means to me. Can we go to the next slide, please? Um, what is traffic engineering and what does it actually mean in the ITF context, right? So if you go searching for a definition in the ITF documents, you will find that traffic engineering is defined as that discipline in network engineering that deals with issues of performance evaluation and performance optimization of operational networks. But if you dig deeper in more simpler terms, you can think of traffic engineering as that discipline of network engineering that comes into play when you want to control the path taken by the traffic in the network. So anytime you want traffic to follow a path that is not the shortest path, anytime you want traffic to follow a path that's not as computed by your routing protocols, you want traffic engineering. Traffic engineering helps you optimize your resources. It helps you engineer your way around failures and outages. It helps you ensure reliable traffic delivery, and in short, it helps you make the network more predictable. Next slide. So there are fundamentally 3 key elements that you would find in some form or the other in any traffic engineering solution toolkit, if you will, that is built using IDF technologies. Um, you have these T policy tools that allow for selection of paths based on information beyond just basic reachability, right? So these policy decisions can be made within the control plane or by controllers. Then we have the T path steering tools that give the ability to forward packets using more information than just knowledge of the next stop. Um, RSVPT explicit routes or even segment routing, path steering are good examples of this. The third key element is resource management. Resource management provides resource aware control and forwarding. So when I say resources, think of bandwidth, think of buffers and queues, think of any resources which can be managed to control loss and latency. Um, there are two aspects to resource management. There's the control aspect, which is what we refer to as resource reservation, which provides sort of domain-wide consensus about which network resources are used by a particular flow. There's also the data plane aspect of resource management, which is called resource allocation in our documents. This provides for the allocation of specific node and link resources to specific flows. So in a nutshell, if you look at all the key tools provided by IETF technologies, you'll find tools that will let you learn about the topological elements and the various attributes. You'll find tools that will let you compute paths, either centrally or distributed using various constraints and optimization objectives. There'll be tools that will help you signal these paths and provision them. There'll be tools that help you map services over these paths and um, also help maintain these paths across various failure scenarios and outages. Uh, can we go to the next slide? So with that um, introduction about traffic engineering, let me um, dwell a bit on the TEAS working group and its activities. So as the name suggests, the TEAS working group is responsible for defining traffic engineering architecture and signaling standards in the routing area. The working group itself was started only in 2014. It was part of a major reorganization of working groups in the routing area. So what you see here on the slide is a slightly condensed version of the working group charter. We, as a working group, are responsible for the T architectures for anything that has generic applicability across both packet and non-packet networks. This includes both centralized computation and control, or distributed computation and control, or a combination of the two. We are also responsible for all the T mechanisms and extensions that span multiple domains or multiple switching layers. We work closely with working groups like LSR and IDR that cover the traffic engineering extensions and protocols like OSPF, ISIS, and BGP. We also work closely with TCE, where the PCEP extensions are defined. So the functional specification itself is done in T's, while the extensions are done in the other relevant working groups. We are responsible for all generic extensions to the RSVPT signaling protocol. And lastly, we are responsible for the definition and extension of management and security techniques for T-path control. And this includes any related OM work or any related modeling or MIB work. Next slide. So this is a laundry list. We have produced about 27 RFCs in the last 7 years. That's about roughly one RFC per quarter. So that's a fairly decent run rate, given that we produce a fair number of architecture and framework documents that require lots of debate and discussion. Of the 27 that we have produced so far, 14 are proposed standard. 10 of those are informational documents. Two are experimental. Meaning there is more work to be done before they can proceed to propose standard. And then there's one which is a best current practice document. And while I'm on this slide, let me highlight a few favorites, plug a few RFCs for your reading. So RFC 7926, which is a best current practice document, is my go-to guide for all things related to interdomain traffic engineering. RFC 8283. It's an informational document that discusses the architecture for the use of PCE as a centralized controller. I'm sure you'll hear about the PCE as a centralized controller work in Drew's talk later as well. The third document I would plug is RFC 8370, which is a proposed standard document that discusses techniques that significantly improve the scalability of RSVPT deployments. And then lastly, there is RFC 8795, which took about 6 years or so to get done, but it is the proposed standard and my go-to guide for anything to do with T topology modeling. Can we go to the next slide? This slide gives you an overview of our ongoing work. Um, there is a lot of data modeling work that's currently happening. There are weekly open design meetings that are happening for some of these. So if you work for a vendor, I would strongly encourage you to compare your native schema with the young models that are being developed and check for implementation feasibility. Most of these are nearing completion, so now would be a good time to get some thorough reviews in. RFC 3272, it's an ITF classic, discusses the principles of internet traffic engineering. The only problem with that is that it was published about 2 decades back and is a bit outdated. So what we have done is we revisited the document, we have rewritten it for the most part and make it more relevant to the current times. And hopefully this will last for another 2 decades. ACTN, which stands for abstraction and control of T networks. It's an umbrella term for a set of management and control functions used to operate T networks to construct virtual networks, and those can be presented as a service to the customers. The framework for ACTN has already been published as an RFC. We are now looking at how ACTN can apply to areas like packet optical integration or network slicing. Enhanced VPN is another framework that's in the works that caters to enhanced connectivity services. There is a fair bit of discussion about its applicability to network slicing that's ongoing. Then there is the topic of network slicing itself, which is a huge topic. It has been hogging a lot of airtime in recent TEAS working group sessions. We have a working group adopted framework document, and there are various solution-specific documents that are being thoroughly debated and discussed. Um, Also, we do have a few GM pillar specific items in flux, things like the protocol extensions for shared mesh protection. Uh, those are nearing completion, and they're likely to progress to publication stage pretty soon. Next slide. Um, so that was about what's happening in TEAS. Let me change gears a bit and talk about tips of participating in TEAS or ITF in general. So as you all know, ITF is the premier standards body for the internet. If you work in the internet space, then you all understand the need for these standards. You need these standards to build your networks. You need these standards to implement your software or build your hardware. And the only way, and I repeat, the only way you can influence what's in the standards is by directly participating in the standardization process. Uh, Participation is quite easy. ITF is open to everyone. There are absolutely no barriers of any kind to participation. You can pick an ID that's related to a topic of interest, read it, discuss it on the list, ask questions, point out the problems, try and make the solutions work better. Um, Reviews of documents in any form whatsoever are greatly appreciated and are always very welcome. So if you start by doing this, and I promise you, very soon you will find yourself bringing in new ideas and discussing them. You can get people to build solutions to your problems, and that's a great thing. Of late, many working groups have also started using these open design team meetings to push certain key deliverables. These are meetings that are driven by the authors of the relevant documents and are open to everyone who wish to participate. In TEAS, there are regular weekly meetings and also bi-weekly in certain cases uh, to progress most of the modeling work. So these meetings are announced on the list, and depending on the topic, they can be a very good avenue for you to ease yourself into the ITF process. There is also an ITF hackathon that happens at each ITF meeting. You can come write code in these hackathons. There are lots of open source efforts that attempt to implement the drafts that are being produced. You can contribute there as well, and those would certainly help us enhance the quality of these documents. Next slide. Before I wrap things up, let me talk a bit about my personal journey with ITF. As part of my first job, I was 21. I had to develop a module for a HTTP server, and I had no clue. And I was asked by my manager to refer to the HTTP 1.1 RFC, I believe. That was really the first time I went over an IETF document in depth. I remember not enjoying it too much then. That's probably the reason why it became obsolete in a couple of years. Um, I started following the IETF working group mailing list a couple of years later when I began developing MPLS features. And um, I eventually became an active contributor to the IETF process because, like I said, that is the only way I could uh, further the progress of documents that I deeply cared about. I started attending in-person meetings around 2010, and come 2015, when the then routing area AD asked me if I was interested in serving as a co-chair for the TEAS working group, I didn't have to think twice about saying yes. Though it started with a job-related force initiation, the steady increase in the degree of my involvement thereafter has definitely been driven by a genuine belief in the IDF's mission, a belief in the mission that wants to make the internet work better by producing high quality, relevant technical documents. And after all these years, I'm still happy to be involved with the ITF. I'm excited to talk about it and help bring in new participants to the ITF. So that's been my journey. That's all I have in terms of slideware. I can take questions now. I'll also be around till the end of the session, so feel free to reach out if you have any questions or traffic engineering in general, on or either on TEAS or traffic engineering in general. Um, Let me see if there are any questions.
Pawan, there was one question in the chat as well. So let me ask that question first, and so for participants as well. And Rama, if you would like to speak, just send me a message. I will give you permission to talk as well. So the question is, with the invention of segment routing and SRv6, and now there is FlexAlgo as well, how does this impact RSVP? Does the RSVP still useful and it's some major deployments out there, or has segment routing overtaken that?
Segment routing has been around for quite some time now. It's no longer this new thing. I think it's been roughly 7 years now, so 6 to 7 years now. Uh, the truth is that we still have lots of major RSVP deployments out there. There are lots of deployments that run the networks hot, and bandwidth engineering is something that's very key for those deployments. And RSVPT still is the technology that provides them the best bet for catering to those requirements. Yes, segment routing is uh, taking rapid strides, but there is room. I mean, personally, I do believe that there will continue to be a room for RSVPT.
Thanks, Pawan. And I think there is one more question now from Vishal, which is traffic engineering applies from routing layer based on the presentation that you have given. He's asking, what about other layers? Is there traffic engineering in application layer, for instance?
Um, there are uh, there's definitely traffic engineering that can apply to the application layer as well. In TEAS, we are dealing with problems in the routing area, at the IP layer and the transport layers. But yeah, I mean, you can apply the same principles that I mentioned about path computation, path placement, path maintenance in higher layers as well.
I don't see any questions. So, Pawan, let me ask one question from my end as well. Since Tease has been involved in Yang modeling for such a long time, and they, as you also mentioned, that they have been proposing lots of Yang data model. What's your take on, like, how successful has this whole endeavor in ITF with Yang modeling has been? What are the lesson learned, or anything you would like to share?
It's been slow. It's been very slow. When we started the work in ITF, there was also this open config consortium that was also developing relevant data models in parallel. Because open config is driven by operators, we have seen lots of vendors uh, uh, add support for the open config models, more support for open config than for IETF models. I see that changing over the last couple of years or so. There are requests coming in for support for IETF models as well. The 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 good thing going for IETF models is that, I mean, there's more there are more people involved in the development of these, and there are lots of vendors who try to make sure that models are developed in such a way that are easily implementable as well. When If the models are developed by the operators themselves, I mean, uh, it's a slightly there's a slightly different perspective behind developing those models, and not all of those tend to be easily implementable or mappable to one's native schema. um, there is still a lot of work to be done. It's good to see some models at a very mature stage. There are deployments for some of those IETF data models, but there's still a long way to go. And it's good to see that there is starting. I mean, it's good to see some traction in terms of requests coming in from customers as well.
Thanks, Pawan. Pawan, there's one last question. Traffic engineering based on TOS and DSCP fields, can it be taken to next step? Can we add API which are application based?
There is some work that's currently being done in Tees and also elsewhere. So diffs has always been there. It's just that the it didn't take off in a major way when it was first deployed. But there have been efforts in recent times, things like network slicing coming in. There is a need to take diffs to the next level. And if you look at some of the recent work in network slicing, you will find some pointers that are trying to work in the space.
Thanks, Pawan. Praneeth, off to you.
Thank you, Pawan, for the insightful talk. And if any of you are interested in the TEEP working group, please feel free to follow the mailing list. We'd love to take more questions, but in the interest of time, we have to proceed. But feel free to use the Q&A if you still have any more questions. Next, we have Shweta, who is the principal engineer at ThoughtSpot and a very active contributor to IETF since the year 2008. She's currently co-authoring Institute OEM related work, and she serves as the IETF Ops and IoT Directorate. Shweta is one of my personal favorites also because she is involved with 6LO working group, with which I actually started my development career. So without further delay, off to you, Shweta.
Thank you, Praneeth. The next slide. So I have spent most of my career at building my career at Cisco. I spent working on a variety of protocols in different areas, which I'll cover at the end of this topic. Right now, I do work on the cloud infrastructure and security, securing the cloud infrastructure for a distributed data analytics application at ThoughtSpot. I have been involved in IETF in a variety of areas, majorly in the IPv6 int area focused work groups. As part of that, I started co-chairing IPv6 for low power constrained nodes from 2019. Next slide. So what we'll do is we'll talk a little bit about 6LO work group itself, what it does, what is its charter, and how it fits into the IoT ecosystem. The when we say low power constrained nodes, typically you would think about them in the IoT space, and that's very relevant to a lot of people in India, especially because we have startups, we have companies working with focus on IoT, and also in the deployment, it's a very interesting area. Like Praneeth mentioned, it was one of her starting areas to contribute in the internet space. I also know others and people from IISc, SVR, Anand sir, who have been very active in this space. And I'm sure there will be more of you who would be interested and would want to contribute here. Then we'll conclude the discussion with what other areas and how I've been involved, just to give an idea about how you can go about it as well. So to start with, 6LoW has been focused. It was a follow-up to a previous work group called 6LoWPAN, which started with defining IPv6 to be used in the constraint objects. What do you mean by constraint nodes? Constraint nodes are those which are constrained in terms of power usage and other resources like memory and compute. Okay, when we have such this kind of adds an upper bound to how much of processing you can do on these nodes, how much of data you can store on these nodes, as well as in order to optimize the power. These nodes are typically asleep; they are not always awake like our typical laptops and desktops and servers, which constrains the kind of protocols that they can run, and also how you are active on the network, how the applications are built on top of these nodes to limit the usage of network bandwidth, as well as these are mostly wireless focused technologies, which have limitations. Which lead to a larger energy consumption when they are awake, and so you would want to optimize the protocols on top of these mediums to be more energy efficient. The other limitation that we have in these types of networks and media are limitations of broadcast and multicast medium available, which we make use of in classical Ethernet. We use a lot of broadcast and multicast medium for keeping our protocols active. So those are constrained, and hence you need things like that we develop at 6LoWPAN and now at 6LoW and other related areas to make the constrained node operational and optimized with the constraints that they have. So the main charter that 6LoW is responsible for is to build adaptation layers for a variety of lower layer technologies. You name it. You have Bluetooth Low Energy, you have DECT ULE, there is NFC PLC, there is also ITU defined G9959. These are the lowest layers, which on top of which we still want to run IP. What would happen if you don't run IP? Typically, what in absence of these adaptation layer, what had started was proprietary protocols and then a bunch of gateways and translation layers developed, and proprietary application appliances that had to be deployed in order to connect these constrained nodes and network them to the rest of the internet. So the adaptation layer started with 802.15.4 adaptation layer that was developed by the 6LoWPAN work group that has now concluded. Now any new adaptation layer required for the other constrained mediums for those nodes are being developed at 6LoW. So that's one area of work where you will see a lot of ongoing work and RFCs that have been contributed from the 6LoW work group. The second part of our charter, the 6LoW work group charter, is to develop how to manage, monitor, troubleshoot these networks better. So you will see some one RFC around the MIB that was developed. We haven't done so much of work in the YANG because it fits in with the rest of the IPv6 areas, and that's being developed for the classical IPv6, which still applies here. Then, as I mentioned, the constraint nodes have limitation in amount of code compute cycles that they can run, and we also want to limit the network bandwidth and overhead that protocols have. So there is an active area in 6LoW where where we have proposals and standards being developed in header compression. Instead of using the standard IPv6 40 byte header, there are a lot of mechanisms that are proposed in the earlier in 6LoWPAN. That was the first where we developed header compressions to compress the 40 byte IPv6 header to something like 3 to 4 byte in the best case header. Plus, also the UDP header compression was proposed as part of 6LoWPAN, which has been carried out and is generically applied for other types of link layers as well. The next part of the charter which 6LoW has contributed to is neighbor discovery optimization. The classical neighbor discovery has been mostly defined with serial links and shared transmit media in mind, where the broadcast multicast was cheap, right? So it relies a lot on caching in the nodes which participate in the neighbor discovery and multicast operations for both lookup and duplicate address reduction. This obviously from the constraint nodes is not preferable, so we need to optimize it. So there have been a lot of RFCs and drafts that are in the area of neighbor discovery ND optimization. And of course, other than this, we continue to, since 6LoWPAN has concluded, 6LoW continues to support and maintain the drafts that came out before 6LoW was formed. Next slide. So here's an example of how this fits in, how IoT ecosystem, IETF contributes to IoT ecosystem. And there was, I think this paper came out, the white paper came out in about 2020. I have a reference to it in this slide. Should definitely look up, which has a lot more details than what I'm going to be able to cover today. So if you think of IETFs, there are, we organize in areas, and the 6LoW doesn't exist in isolation. It works with a large number of other work groups together, with all of these together help in deploying IoT solutions. Okay, so if you take I'm just giving a very, very high level, what are the areas, what kind of RFCs you can start looking at to, in order to get a grip on the IoT space with respect to IETF. So let's start with what we are most used to. What do we use in place of HTTP in the constrained network? Right. So in the low power lossy networks, the application layer is also being optimized. So that's what the application area work groups have done. So the core work group that was in the application area has developed a protocol called COAP, Constrained Application Protocol, which fits in which still gives you the RESTful semantics, but operates in the IoT environment, because it works on UDP layer. It has been optimized to be more lightweight and can easily be proxied for HTTP, right? So when the low power networks connect with the regular internet based network, so you can bridge them together easily, because COAP has similar semantics to HTTP and it makes it easy to bridge them. So those were developed in the application area. Even the routing has been optimized for the IoT, so you should definitely read the routing protocol for IPv6 routing protocol for low power lossy networks, developed by the ROL work group, which has a bunch of RFCs. I have just added RFC 6550, which at least was a starting point for me to understand how the distance vector based routing works. For example, the link state protocols that we typically deploy OSPF and other protocols that we have active in general internet will not work in the constrained environments because of their chattiness, their reliance on a lot of state being distributed, shared, and kept active. While in RPL was developed with constrained networks in mind, so it builds on top of what we call as the destination-oriented directed acyclic graph-based routing. It's a distance vector routing protocol which doesn't assume that all the nodes are active all the time. The topology is very dynamic. The LLN networks, the topology keeps changing because nodes go to sleep, move around. So with that in mind, the RPL was developed. So you should definitely, that's a very interesting set of RFCs that are that will initiate you into the IoT world if you are new. And even if you are seasoned, if you are not used to the routing protocol, how it should be different from the regular internet routing protocols, this would be a good starting point. Then we come to the connectivity area, mostly where there are a number of work groups where 6LoW fits in. So 6LoWPAN has concluded, but the RFCs that were developed by 6LoWPAN, ND optimization, the first RFC 6775 is the go-to for me and would be a good starting point for anybody who wants to start looking at the what are the optimization that we need for ND and what have been developed. Right, and from the adaptation layer, the one which was developed for 802.15 for RFC 4944 is the starting point, which makes it easy for us to understand the other optimizations and new adaptation layers that have been proposed for BLE, for PLC, for NFC, right? And others also, and others as well, which are in the 6LoW work group, developed, discussed, and couple of them are going through the ISG process. That would be interesting. And header compression continues to be interesting, right? So it was 6282 was the 6LoWPAN developed header compression, which compressed V6 headers, V6 plus UDP header, if you see, would be typically 48 bytes, and with the compression that 6282 offers, it can be compressed in a link local network where you use link local addresses. So it can be compressed to almost from 48 to 6 bytes, and if you need global interactions, to go from 48 to 7 bytes. But you will see in the next slide, we have new proposals in 6LoW work group, which makes use of Chic, which is static context header compression and fragmentation, which was developed by the LoWPAN LPWAN work group. The framework was developed but it is being discussed and taken up in 6LoW area. There are very interesting proposals to compress it even further to almost 1 byte from 48 bytes, and additional compressions which can be done for the co-op layer, which has not been done so far. And you would be wondering, what about security? How can we, because security itself will have additional overhead. Yes, it does. We can't deploy TLS like security. So TLS work group itself developed datagram security layer, because mostly UDP is better suited in this kind of environment than TCP. So DTLS is another area if you want to understand how security can be, how transport layer security can be developed, can be deployed for constrained networks. Next slide. So 6LoW has published a number of RFCs in the chartered space. There are about 17 RFCs published, and we continue to, it's an active work group, and more recently we are seeing the other three, more than that, like the adaptation layers are ongoing. They keep coming from Wi-Fi Sun and other bodies that develop the link layer. they bring in the work to build the adaptation layer so that IPv6 connectivity can be built on top of those link layers. But we do also see interesting work. For example, the newly adopted work group draft that was around multicast registration. So so far we have 8505 was the RFC that led to address registration instead of discovery, and the node responsible for the unicast address being always awake and responding to the address lookup request. Typically in the IPv6, in the constraint network space, what would happen is you will have not so constrained nodes like the in 6LoW has defined terms like 6LoW routers and border routers that connect the very constrained nodes to the LLN networks and LLN networks to the rest of the internet, right? So in this space, it was very focused on unicast address registration and connectivity for the unicast addresses. So Pascal and team have proposed multicast address registration, which has now been adopted and discussed, and any additional extensions required for RPL, additional options and header extension required for RPL for supporting multicast based routing in this or reachability for multicast addresses in this space. More recently, these are all individual work group items that are being discussed in the last two IETF work groups we met as part of the 6LoW meetings. So those are around header compression. Like I mentioned, Sheik has been discussed and applied in a more generic way for 15.4 and other link layers, which 6LoW is responsible for. And there are newer proposals which even are more drastic, where they define newer, shorter addresses and even own routing solutions that are discussed. We will have to have a lot more discussion and consensus to be built in order to adopt some of this work. So we definitely would require more eyes, more people to come and contribute in this. Even reviews would be very, very helpful, because they are so diverse areas. The people would be more familiar with the newer link layers that they are working on, and applicability of the adaptation layers that are being proposed. We need reviewers in this area. There is also a neighbor discovery unicast lookup that Pascal has proposed. We have had initial discussions around this. We need more people to understand, review, contribute in this area of 6LoW. And in terms of contribution, reviews are definitely welcome. New work items that applies to IoT ecosystem as it continues to evolve are welcome. And all the things that Pawan already spoke about on how you can contribute to TEAS and in general to ITF applies to 6LoW as well. Two other things that we definitely would be interested in, and I'm sure other work group chairs would also be interested in getting people to shepherd the drafts, right? So if perhaps Dhruv and others can talk about how, or maybe we can, as part of the connections, we can talk about how our drafts to RFC journey happens. And as part of this journey, when the work group adopts the draft, then to get it to the ISG review state, we need, other than the author, somebody who can shepherd the draft, who will be responsible for reviewing and making sure that the draft fits into the, is ready for ISG shepherding. So we would definitely invite more people to shepherd the existing drafts, which will be very, very helpful contribution for 6LoW work group, and I'm sure others as well. And lastly, we typically have work group meetings and ask for people to take minutes, and that's no less of a contribution. Taking minutes and being active during the work group meeting to help with detailed notes that can be taken as action items, and we can further discuss in the mailer list is always welcome. So minutes and shepherding is definitely another way of contributing to these work groups. Next slide. So switching gears a bit, I'll just talk about how I started being active, and IETF is part of my journey now, my career and my life in general, because it has made you it makes us think about how to be more articulate and build an internet that serves a larger community in general, right? Including this group, which is very focused on increasing internet participation, IETF participation in India, which has been quite revealing and has built an extended community. The journey itself, it closely resembles how my career has developed. So I started play space. So radius better options, finding gaps in the diameter application, and it was completely remote for the first 4 years of participation. It almost became an RFC from draft to RFC. It went with completely remote participation, right? Then I was more like in-person meetings. I started attending in 2012. Again, the focus areas was DHCP, DNS, DNS, and IPv6. And ever since that, I think traveling of the live meetings throughout the areas other than the work group contributions, which was very interesting to me, which helped me connect with the community, was and bits and bytes stopped, but bits and bytes was used to be like this, where people would demo their area of work. So
Shweta, your voice is breaking.
I developed
Hello. Hello.
Shweta, maybe disable the video. I think you are having some bandwidth issue at your.
As I stop my video. Is
Yeah.
it any better?
Yeah, slightly. And anyway, we are a little bit over time.
Okay.
So yeah, wrap it up. Thank you.
Thanks.
Shweta, go ahead. Finish your.
I know my system is in high CPU, so I don't know. It's not the network; it's the system that is. I don't know how much you'll be able to listen to me. But other than what Pawan said, the areas of interest for people to contribute now, it's possible to do it even remote. Is hackathon, and there are lots of open source projects which would help. And I was part of the FDIO VPP. We developed some of the extensions that we were experimenting with. So that said, I think I have added the links to my active work areas that I and the people I work with have been continuing to contribute. So feel free to ask. In the interest of time and my network and system issues, I will stop here. Thank you, everyone.
Thanks, Shweta. Shweta, just one very quick question, which is in the Q&A, where the question is kind of basic, asking why IPv6 and IoT? What is the main reason? Is it the device number of IoT device count in the network?
Of course, yeah. So V4 addresses wouldn't scale to the number of things that would be part of the network, which IoT would extend our internet to. So IPv6 was the obvious choice.
Yeah, thanks, Shweta. So before we move to Thiru, just one small thing that in this year in connections, as well as after that, we are going to focus on IoT quite a bit. We are trying to make IoT as one of our key focus for this year. We are also partnering with one of the universities to develop a MOOC course, which is a massive online course on IoT. And we will do the online course plus our webinars as a series going forward. So look out for those announcements. We'll most probably start with them after connections, that is after April. All of this will start. So looking forward to people who are interested in IoT to participate in that. And off to you, Praneeth.
Thank you so much, Shweta, for walking us through the 6LO working group in such great detail. So very quickly now, I'll just introduce Thiru. Thiru is working as a principal lead engineer in Akamai, and his expertise is network and IoT endpoint security. He's the chair of Deep Working Group and a member of the security area review team at IETF, and he has co-authored 27 RFCs. So off to you, Thiru. Thank you so much for joining us.
Hey, thanks, Praneeth. Hey, that was a great introductions from Shweta and Vishnu. So I'll start about the next slide, please. The Deep Working Group is relatively a much newer working group that started around 3 to 4 years back. The primary reason why it started was there's a lot of work happening outside IETF with regard to trusted execution environment, which is basically an isolated environment within your processor. This is being developed by any chip vendor like Intel or ARM or anyone who want to make sure that whatever data you have or secure data that you have or some specific secure code that you want to run needs to be run in an isolated environment away from your rich OS apps. Basically, for example, if you want to keep your, let's say, your passwords safe from any breach or a malware happening on your mobile device or laptop, how do you protect your passwords? The other example could be, hey, I'm using a blockchain application and I have my private keys for which are typically stored in a separate vault. How could I do that on my mobile device or a laptop without having to have a separate chip connected to my mobile device or a laptop, right? So that triggered the whole reason why trusted execution environment started, and it became more popular with IoT devices bringing in several security functionalities like your door locks, and they would have all your biometrics embedded within that. How do you protect those confidential data from being misused by attackers by, let's say, invading the IoT device and stealing those important credentials, right? So that triggered the way TE came in picture, and there was a lot of work happening. But the bigger problem was, how do you provision apps, the trusted apps, to run in the trusted execution environment away from your any other app that you typically install on your OSs or mobile devices. So that was the whole intent of why the trusted execution environment provisioning working group was started. The purpose of it was to install, update, delete trusted applications in TE. And the working group is being primarily focused. It's a very small working group with focused people from operating systems, IoT vendors, and Intel and ARM basically contributing to make sure this protocol works so that they can provision more and more trusted applications within TE. And that would create that segregation between the rich apps and the trusted apps that are running in TE. For example, your authentication protocol could be run within TE itself. And one of the big use cases that I see, especially in today's world, is passwords get breached all the time, and there is a huge outcry that we should go to a passwordless scheme. And the passwordless scheme comes from having client certs, basically. With client certs, the challenge is, why do you store the cert? The cert will have your, along with the cert, you will have to have your private key stored somewhere securely. And that is one beginning where if you could store your private key in your trusted execution environment, and your authentication protocol itself would run in TE, whereas all the TCP layer, HTTP protocol parsing would run in the rich OS. It creates a clear distinction between what secure code needs to be run, where my confidential data like private keys or passwords could be stored. And even if my device gets infected with a malware, I can be pretty sure that it won't be breached and I don't lose the credentials. Especially in the last 4 years, if you see after the COVID time, if you see there's a tremendous exponential increase in the number of cyber attacks where accounts have been breached and taken over. Even recently, I saw like LinkedIn had a breach where the passwords were stolen. So TE gives you an flexibility both for endpoint devices and for server workloads, where you can securely store your confidential data in a way that even when your cloud workload gets attacked, and we have seen several such attacks in the last few years, where your cloud workloads, even running within data centers, get compromised. But whatever data that you securely stored in your TE or the code that you run in TE cannot be tampered with, and that gives a great advantage for making sure a breach doesn't hamper your business in any adverse way. Next slide. Yeah, so the protocol is quite straightforward. There is a trusted anchor manager, which is on the extreme left. There's a TEAP broker, which is interfacing with the trusted application manager, which is supposed to provision the TEAP agent with trusted applications, which is on the extreme left side of the screen. So basically, with these two extremes, basically one trying to provision your device with trusted applications, the TEAP broker is basically providing you all the protocol mechanisms to transfer those messages, which are having object security beyond what TLS gives you, to make sure it's actually coming from TAM, and the TEAP agent would know it's actually coming from TAM, and vice versa for the TAM to know it's actually the TEAP agent which is talking to. So the TEAP working group has just 4 working group documents. One is the architecture document, which we recently concluded, and it's going for ISEG review. And then there are this protocol and transport documents, which are almost in a stage of getting concluded. As we are very active in the hackathon, where a lot of interop has been done with regard to the TEAP protocol and transport across vendors to make sure that this provisioning protocol would work. And I think I saw a lot of good feedback coming back from the hackathon, which helped this protocol to transform. TEAP working group protocol, just like Shweta was mentioning, is very much dependent on other working groups, like she was mentioning in the, especially in the security area, like the SUIT working group or RATS working group. And we primarily rely on these working groups for providing us manifests, attestation, and all the other information. So that I believe we will conclude this working group probably by the end of this year. And definitely, if anyone is interested in making sure their apps are secure and are protected from any malware, can definitely look at the work happening in TEAP. And if you're working for any fintech or an e-commerce kind of a one, you can definitely look at this work. And if you're working on workloads which are dealing with confidential data, TEAP is the one I would definitely ask to look into and leverage its functionalities, because now everybody is coming up with, even your public clouds, your endpoints, or your mobile device, everybody is now equipped with trusted execution environment. And that changes the game, that we can now give lot more better security than that was possible previously. Next slide, please. So I mean, just like Shweta, right? Shweta and I worked for a very long time at Cisco. I spent around close to 12 years at Cisco. I started my journey with IATF around 2012. That was my first trip to Paris, which was both a wonderful trip to Paris to see the place, and as well as to attend IETF, which was a very overwhelming session for me, because there's so many working groups and I was lost in my first one. But I finally figured out my way to steer around what working groups interest me and where do you want to focus. So I think it took me a couple of years to understand how IETF works, and then start reviewing documents. I started submitting drafts. Many of them in the early days were going through a lot of discussions, were not making progress. I had to do course corrections. I worked with several members, both within Cisco and outside Cisco, with various companies, around 30-40 people across, with whom I have co-authored and wrote several RFCs, and I'm just listed few of them which became very popular. WebRTC is very popular, that browser support for us to make VoIP calls. I wrote several specifications in that working group. I was instrumental in developing DNS over TLS, which is to encrypt your DNS, and that's, I think, caught the eye of everyone beyond our imagination when we developed this, and now everybody talks about encrypting DNS to give both security and privacy. One of the other works that I did, which was primarily useful for both Cisco and my current company, is Ddos Mitigation, and that was providing a mechanism for the victim to basically talk to the DDoS mitigation provider to have the mitigation scrubbing center click in its resources to protect it. And that was a tremendous journey with regard to, and surprisingly, if you look at Dots, nobody would have imagined we started leveraging CoAP protocol for that, because it was very lightweight and we were running in an extreme network condition, just like what Shweta was saying. But yeah, because of those DDoS attacks, it was supposed to run with a very lightweight protocol that would survive extreme network congestion scenarios. I developed several other specifications with regard to CoAP, peer-to-peer VoIP calls, which is used by any VoIP application that you use today, enhancing your media calls to use DTLS. Basically, DTLS is used for UDP and TLS is used for TCP. So migrating that from keys exchanged in SIP to DTLS was a big transition that's used by any of the SIP gateways today. So I've worked across 7 to 8 or more working groups. I lost count, but I would conclude saying that ITF really transformed the way that I think about the problems that I have to solve for the industry and for the internet, and to make it better. And in that process, collaborating with people across companies and across cultures and working in different time zones, I think it just grooms you as a person to be better technical individual, and have and have a listening ear to understand concerns from people who have a different perspective to the problem that you look into. And yeah, there was no looking back after that. And yeah, it's a great journey for me. And yeah, and I would encourage everyone who's new to IETF to pick up a couple of working groups or BOFs, the new charters where working groups will be created. Jump in where you have really passion, and it could be outside your day job, but it's worth the effort that you take those extra couple of hours, review those documents, figure out what's happening, talk to people, write your first draft. Anybody in this committee can help you out with reviewing your draft, making course corrections, even pointing you to people who can help you with those specifications. And I'm looking forward to more participation from the people attending this session.
Thank you so much, Thiru. Dhruv, do we have any questions?
No, we don't have any questions, but Thiru, excellent work. I think one of our aims here as well was to show that, like, the diversity of people that we have here who can help you. So, like, none of us know the internet fully, nobody understands it fully, but we would be able to point you to the right direction. Even with the work that you are doing, you reach out to us, and like Thiru has experience in so many areas. Similarly, Shweta does and Pavan does. So we would be able to help you out and turn you in the right direction. And something which we did not have when we started participating in ITF, right? So now with IISOC and other people, we want to help you out. So the moment you have any questions with respect to ITF participation, please feel free to reach out to us. Thank you.
Yeah, and I also totally resonate with what Thiru said about ITF work could be outside the day job, but it's totally worth it. Believe me, I've been trying my best to get involved. It's not easy, I agree, but it's totally worth it. So since we are a little overboard, I would like to present to you the star of the show and our prime speaker here, Dhruv. So Dhruv has been working with Huawei for the last 18 years, and he has 32 RFCs where he's the main author and contributor. He is the routing directorate and the sergeant at arms for the ITF mailing list. And he's also the president for IISOC and the founding member and secretary for Industry Network Technology Council. It is very interesting to see that Dhruv was awarded the Technical Role Model Award by Zinov and recognized as the technology steward in India. So congrats for that, Dhruv, and you can kick off your presentation now.
Yeah, thanks, Praneeth. Thanks for the kind words. So let's talk about path computation element, something which Pawan started mentioning because it's very much related to traffic engineering and where the centralized mode of traffic engineering comes into place. Next slide, please. Yeah, so let's just talk about first few of the key terms here. So path computation element is basically the entity which does the path computation. So in the traffic engineering case, when you need to figure out paths that need some new constraints, so who the person who does that kind of path computation, that entity is called a PCE. We use a generic word entity because it could be a controller. These days, it's most likely it is a controller. But when the protocol was written, it was like it could just be a spatialized router, it could just be a program, it could be a part of NMS, anything is possible. So it's just an entity that does path computation. These days, it is mostly a part of your central controller or SDN controller, as they say. And who's the client here? The client is the person who needs that path, who's requesting for the path computation. That guy is your client. And the protocol that runs between these two guys, the client and the element, that's your PCEP protocol. The PCEP protocol from the start also was written in such a way that it could be used between the PCEs. And since multi-domain was the key use case from the start, multi-domain and multi-layer path computation, the use of the PCEP protocol as a way for the PCs to communicate with each other was always there. The protocol is actually quite old. It's been chartered in 2004, the first RFC in 2006. And since then, there have been 62 RFCs published. So this is quite a big number. And the main reason why we have such a big number, because PCEP has found use cases in many scenarios. There is a path computation need in many different types of networks, and they all have different requirements, like a normal packet network, optical network, GMPLS. Praneeth, I lost the slides for a minute, but I'll go ahead and continue to talk. And if you want me to share, just let me know. I'll share my screen.
Yeah, I just had a power.
Yeah, no problem. Share your screen when you can. So we have been doing this work in PCEP for various different extensions. And now, next slide. Just go to the next slide now. Yeah. So what was the main motivation? Why did we need this new person called path computation element? Because traffic engineering, as Pawan was saying, goes way back, and PCE was something that was its needs was developed, found to be a little later. What was the main read? The main thing was we wanted some kind of centralized control. And when every node is doing path computation on its own, bandwidth reservation on its own, we did not have a single view of what's happening in the network. And that was, in some cases, found to be a limiting factor. And to do path optimization, path diversity, making sure that we have a clear relationship between the various different paths that we are establishing on a network, you need some kind of centralized control. At the same time, we all know, like, SDN in the last 10 years, some cases pretty successful, some cases not so much, maybe did not deliver everything that it kind of promised. But the idea was always there. The need was there that we need a centralized place to view what's happening in the network, as well as make some control over things. There's a need for a global view. And PCE was the PCE was developed much before SDN as a term was even existed. And the reason was the same, that we wanted some place to have a centralized control. At the same time, doing multi-domain and multi-layer was a key motivation. And that's why PCEs coordinating with each other is always been important in the PCEP working group, whether it's peer relationship or whether it's a hierarchy relationship where you have a parent PC and a child PC. Those things have been pretty key. And what does PCEP working group does in this case? It comes up with mechanism on how the PCs coordinate with each other to do path computation. How would they do path control, as well as hiding information from one domain to another. Next slide. So what is the main job of our working group? It's to actually write the protocol. As Pawan was mentioning, the actual architecture belongs to T's working group. So we do a lot of work in coordination with them when we need to do some architectural change. And one of the architectural change that Pawan also was mentioning was PC as a central control. A sort of PC not just used between a head node and the PC server, but also controlling the hops across the path in the network, sort of like in a SDN fashion. So that work also got done in the T's working group, but the extensions, we published our first RFC in PCEP extension for a static LSP sort of setup. That's where PCEP protocol comes and do the play. We had quite a bit of a journey. Like we initially was completely stateless. That is, it is PCC asks for a path, PC computes the path and completely forgets it. It doesn't remember what's the path that is set up. Now, of course, that had some limitation. And for us to do complex path computation, where we need to maintain the relationship between various different paths in the that we are setting up, think diversity, think like, even now the new think like network slicing, it would be kind of very difficult to have those use cases established in a stateless world. We needed the PCE to be stateful, maintain all the information that is happening in the network, and also have a capability to initiate things. Think how in SDN terms we talk about programmatically, something like that in PCEP world as well. Another key thing that we have done in PCEP is that it's not bound to one signaling mechanism. PCEP use happens in for RSPPT, it can be used for SR, and in fact, even SRv6, which some people would think like, just IP layer, but even for IP paths, PCEP comes and plays a role. I talked about SDN, as well as not just IP, but GMPLS, WSON. So there have been a lot of extensions to PCEP based on various different data plane technologies that exist in CCAMP working group as well. So this is a quick summary of the PC working group. Next slide. So what is the key work that is still happening? I have put them into 4 main buckets. I was mentioning about stateful PC. That remains a key topic. There have been new use cases to extend them, new associations, because the relationship between the paths is the key. And so to establish that, there have been new association type, how to synchronize state better, all that stuff. Then a lot of things which are SDN-like. We have RFC 9050, which is our PCCC first extension RFCs, but a lot of work is coming for segment routing, SRv6, P2MP, native IP, that is like, normal IP network as well. Segment routing is hot, and that's why there is a lot of extension in PCEP for that. How do we do SR policy handling, path segment? We just did a binding segment draft to ISG. How to do bidirectionality in segment routing, SRv6, all of them are quite key. And lately in other working groups like PIM and BEER, there have been work for SR P2MP policy. BEER has been doing a lot of BEER TE. Again, that will be our next set of keywords, key work that will come to PCEP working group. So mostly what happens is, as and when the architecture works happen somewhere else, in T's working group, in Spring working group, in PIM working group, the actual extension, when they realize that PCE is a good protocol to achieve that architecture, that extension comes to us. So we do have to coordinate with lots of other working groups to make sure that the extensions works correctly. And in fact, one of the key things that has happened is BGP and PCEP have been extended to meet a lot of these use cases, because some people have preference over BGP. They would like to use BGP as a protocol to do segment routing, for instance, and some people prefer PCEP. So there is some alignment that is needed, even like think of how OSPF and ISIs get enhanced in the same way, so that we try to maintain that the use cases can be established by both the protocols out there. Next slide. So how could you contribute to this working group? Actually, the working group has a lot of pending work, so we do need your help. So if this PC has ever interested you, segment routing has ever interested you, take a PC document and help us out. And why we need help? We have currently 19 working group drafts, which are already adopted. So a lot of ongoing work, which is not finalized yet. So you still have a way to input some of the work, which is almost ready, but it needs just last work. So there are 8 documents that we have in our working group last call queue. We maintain all of that information in our working group wiki, which is right here. And even if you search PC working group wiki, you will able to find this link. And there you will see, like, how the chairs are going to progress the work. So you will know which document would be a good document for me to review. And we do need reviewers, as I said, because there are so much pending work in our queues here. And this is pending mainly because we would need to make sure that the work has gone enough eyes, there are enough reviewers, enough implementations out there, that we have got the implementation feedback. Because as you know, once RFCs are published, they do not change. So we need to make sure that, like, they get enough reviews before we send any documents to ISG, and we need help there. Even authors would immensely find your reviews helpful, because their documents have been waiting in these queues. And reviewers, number of reviews is a very key criteria to make progress in the working group as well. So working group last call and working group adoption, that's a pretty important place for you to contribute. Like once the poll goes in any of the document, that's when authors and working groups are really looking for input. So don't miss out on that. And if this area interests you, please go and contribute. And whenever there is an extensions, even when you have an idea, think about implementing this in open source. Like PSEP, for instance, can be found in Open Daylight. It can found in some other places as well. Think about implementing, and that always gives will help you make progress and even understand your standard and your proposed idea much better when you implement them. And always bring new ideas. PSEP is completely open, as you see that we deal with so many different things. And if you think that your technology needs a central controller, needs a central entity to do path computation, PSEP would be a good place to think about it and discuss its applicability even in new areas. Some new areas which could be thought of as, like, for instance, DetNet is another working group which is thinking whether PCE extension would be needed or not. Service function chaining was one such idea for a while, but it didn't go out that well so far. Okay, since I have 5 more minutes, let's move ahead and let's rush through it. Okay, like everybody's last slide, this is my last slide. How did I got involved? My first ITF was back in 2010. I attended ITF 78 in Maastricht. Why did I attend? I was implementing PSEP protocol for Huawei, and I had some ideas. I found some things lacking, and I said, like, okay, we need to extend the protocol to solve this problem that we are facing. And I wrote my first draft and presented my first draft in ITF 78. So that's how I got involved. And over the time, it was not just PSEP. I got involved in various different other working groups, T, Spring. I, in fact, even did things like NTP, Alto, which is an transport layer, NTP, which is an IP. IP, you have LSR, MPLS, etc. I also took part in some BOPs when you had new ideas. That's actually a pretty interesting time to participate. In working groups, the number of drafts that you have to read is also limited. You have like 1 or 2 initial ideas published as a draft. So you can get involved pretty quick. In some of the older working groups, you actually have a lot of history, sometimes which are like, which is kind of difficult to parse by looking at the archives, etc. I first became actually a working group secretary back in 2017. As a secretary role, you help the chairs with things like minutes, making sure the slides are uploaded, all that kind of stuff. I also shepherded documents, as Shweta was mentioning, as a working group secretary. So that's also a good place to start if you are interested in, like, the admin part of ITF as well. I also part of the routing area directorate back in 2018, and I've been continuing since then. I became the chair in 2019, so I'm a sort of a much recent chair compared to Pavan and others. I also I'm a sergeant at arms, which is kind of sort of a different thing that I got involved in since 2019. Since ITF does all its work on mailing list, we need to make sure that the code of conduct is followed on that mailing list. And that's where the Sergeant of Arms comes in as well. And I have been part of the ITF Normcom. And in fact, in a 10 years gap, I was a part of the recent Normcom, where we have established a new set of IAB members and ISG members, etc. So there's a lot of different ways you can contribute, as people have been already talking about. And my last slide would give you some of my tips to you. Next slide, please. So most of the people have read RFCs. Like if people who are on this call, I'm sure you guys have read RFCs. And when I was also reading RFCs, I was never thinking that, oh, I would actually have a say in writing those documents, right? But the key thing to realize is that your inputs as an implementer, as a reader of the RFCs is very important, because if the things are not clear to you, they are not going to be clear to other people's as well. So if your inputs come in form of reviews of our drafts, we can fix those problems that you would have actually seen when you were implementing RFCs. Oh, this is like kind of complicated, this not described in a clear terms, or something is missing. Those are the inputs that are very important. So as an implementer, as a reader of the RFCs, take part in actually creating those RFCs. And the participation can take various different forms. You can start passive, like, okay, I'm going to start listening in to what's happening in ITF working groups. Let's see what these guys are talking about. At one time, you may think, okay, this idea seems interesting. Let me go and read the document and review it, put my comments. At the same time, while you are discussing that, you may think, oh yeah, maybe this is not the right way to do it. I have a better idea. Then you start as a contributor. So start slow, start with the right mindset, pick a few areas that interest you, because ITF, as it says, is large. Even in a routing area, there are so much different working groups. Pick the areas that interest you. Maybe if you're working in that part, you are implementing it, that's the best. But even if it is not, even if your day job is not too much related to ITF, you all have used some protocols or some things there which has interested you. Pick those, start contributing. And other things are like hackathon is a key thing. If you are an implementer, hackathon is quite useful. If you are a researcher, you are an academician, there is an IRTF, you can participate there. And so find what interests you, whether it's implementation side, research side, your own protocol, and new ideas. Like there are a lot of different venues for you to participate in. And when you are attending a meeting, just don't directly go and attend the meeting and click on the Metaco and you are attending. All the things are posted in advance. So unless you have gone through the agenda, maybe sometimes gone through the slides as well, read a few internet drafts, then only the ITF meetings are easy to parse and understand, because people are talking about updates that they have recently made. They are not giving a presentation like this where we are starting from the basic, right? We are talking about making progress to documents in the ITF meeting. So unless you have gone through the material, the meetings would be very overwhelming and you will feel like, okay, they are not useful to me. So unless you do a little bit of preparation, then only attending ITF live meetings becomes sort of useful. And that's why it takes time. So pick a few sessions where you will do this in depth. And for the other things, don't be shy being a tourist. Okay, I'm going to just attend. Let's see what these guys are talking about. And maybe after the meeting, I will see, oh yeah, this seems interesting. Let me prepare for this maybe for the next meeting and in between the ITF. So from a tourist, you could actually graduate to actual participant into meeting. And we are all here to help. Even in ITF, everybody is there to help. So don't be shy. Please ask for help. And also try to understand how ITF works. What is the ITF culture? And while being a tourist or while being a passive participant in ITF, that's when you get the idea of how ITF culture is. And it's always good to be a part of that culture and respect the boundaries that are there within ITF and how we make progress in ITF. Everybody is volunteering. So you have to be respectful for everybody's time. This is not a paid position. Nobody's getting paid to participate in ITF. So there is something that we need to also respect when we are talking to reviewing other people's document or asking even chairs. Sometimes we get also pushback. Oh, why are you not moving my draft? So that you need to understand how IETF culture works to make good progress within IETF. And I am over time 1 minute. I'm going to shut up. And if there are any questions for me or any of the other people, please let us know. I can even give you the mic access. If you would like to speak, just raise your hands. And Praneeth, otherwise off to you.
Thank you so much, Dhruv. You really summed it up perfectly. This is exactly what we needed to hear. And I think now all of us have a lot of data on how to contribute. We know about the 4 working groups also. So we have some starters, and we would really love to see you all contribute and join our discussions in the IETF and IISOC. Lastly, I would like to remind everyone that now IISOC has a formal membership. So please feel free to join as a member. The links are posted in the chat. And we have connections coming up in April, about which we'll be reaching out on our social media. So keep a lookout for that as well. I would like to thank all the speakers for spending their Saturday afternoon with us, and to all the attendees for joining us on this fine day. Thanks, everyone.
Just one last thing, IETF 113, is coming up. There is a free online participation. I put the link for that also earlier. And in fact, if you are attending, the early bird stops on Monday. So just keep mindful of that. And I hope, I'll see some of your faces in IETF 113 online as well. Thank you. Praneeth, so we are done. Thank you.